So before we get to LINQ, we need to talk about a few foundational C# language elements that LINQ relies heavily on. Once we get some of that syntax out of the way, then we can move on to LINQ proper, and hopefully it'll make a lot more sense when we do that. So let's start off today with talking about object and collection initializers, which are just shortcuts for constructing and initializing new instances of objects and collections. And you need to get this under your belt for a couple of reasons. First of all, it's a time saver. Secondly, it's a lot more elegant than the alternative that we've already been using. And third, it demonstrates your mastery over C# to your fellow developers. And don't underestimate the value of that, because the profession of software development is a meritocracy in which you're essentially awarded status and awarded respect based on your knowledge. So if you take a look on screen here, this is a real example from the previous homework assignment back on day 5. If you already have this, it's the MRU.SLN, the MRU solution. You'll recall that I had you create 2 instances of each of 3 derived classes and then add them to a generic list. And it took me 39 lines of code from about here all the way down to here to create each of the instances of the mutant objects. So what if I could shorten that dramatically, say to 8 lines of code? Let's do this. I'm just going to comment this out and go to the very end here, comment this out, and then I'm just going to copy and paste a shorter section of code here. And then we're going to run the application again to make sure this works. Well, let's make sure this works. Okay, I need to include this as well. Alright, now let's run the application. And it seems to work. Okay, so what's the difference here? Basically, we're using both object and collection initializers all in one shot here. And we're going to go through this example, or at least break down similar examples so that you can see what we're doing here. But just imagine getting rid of all of this code and all of this typing and able to replace it with just that. So here we're doing, essentially what we saw in this first line of code, where we create a new instance of a list of type mutant, and then we have an open bracket at the beginning and a closed bracket with a semicolon at the very end. In between, we have a series of new object names, and embedded within our outer squiggly bracket is another pair of brackets that have the name of the property equals and then some value. Name of the property equals some value, separated by commas, and then this whole line has a comma at the end, which allows us to create additional instances of objects to add to this collection. Okay, so well, let's do this. That might be a little bit much to swallow in one pass. Let's just go through another example that I have here. I'm going to go ahead and save this and give this to you as part of this project. But let's start off here at the beginning. What I have is another project called Object Collection Initializers, and we're going to fill in all these little areas here that I have created as comments in code. I have several classes that I've already created. An order class, and notice that the order class has a couple of features. First of all, it has some constructors, a default constructor and an overridden constructor defined. I also have a number of properties that I have just used the shortcut syntax, auto-implemented properties. Here you can see I have an order items property that's essentially containing a list of order items. Here I have 2 classes that are defined, or properties that are defined as instance of the address class. So here's the order item class and here's an address class. Alright, so just be aware that I'm relying on all of that as we work through these examples. Alright, so from our previous example, we might have done something like this. I'm just going to copy and paste some code in here. So, thinking back to the previous example from lesson 5, we did something very similar to this where we created an instance of an order and then we started setting each of the properties on separate lines equal to their new values. And then we learned that we didn't have to do it that way. We learned how to create a constructor and an overloaded constructor. And here is an instance of creating a new order object and passing in values that would be used by the constructor to initialize the state of the order class or the new instance of the order object. All right. Also, we need to think back to our array initialization syntax. You remember when we were working with arrays? We did something similar to this, where we have defined an array of integers called numbers. And then we use this open bracket, close bracket syntax. We put in a series of values separated by commas. Here's a similar example, but using an array of strings called states. And here we pass in as an initializer an open and close bracket, and then a series of values separated by commas. Well, that's exactly the notion that we use when we're using object initializers. So here, let me copy this third example in. And here, one other thing I want to point out. Okay, so let's start here. We're creating a new instance of an order object right here. And then I have the open bracket syntax. And then I have the property equal to a value. The property equal to a value. And the neat thing about this is, let's get back to the very end of this. I'm just going to go and hit the comma, and notice that we get full IntelliSense here. Equals, I think we can just do 395. So that's another big benefit that was built into the Visual Studio IDE that allows us to use this new feature effectively. We'd be lost without IntelliSense, right? So I wanted to point out one small difference between how these two examples work. This looks almost identical. Stare at it for a moment and tell me if you can spot the difference between these two examples in number 4 and number 5. Okay, so what's going on behind the scenes is that, notice how we define new order here and new order here. This will rely on the default constructor. This will also rely on the default constructor. However, in one case we're explicitly calling it, and the other case we're implicitly calling it. So if we wanted to use one of the constructors, all we need to do is, for example, if we wanted to use our other constructor, we could just get rid of these two arguments and it would use our second constructor because it takes an order ID and an order date, whereas the default constructor doesn't take any arguments. And so then it uses behind the scenes just the normal object initializer functionality to accomplish this task. So just be aware of that and how and what's going on behind the scenes. If it can use an existing constructor, it will. Otherwise, it'll use the default constructor. Okay, so then we move on to a slightly more complicated example. Let me just copy and paste another section of code here. And that is to demonstrate that you can nest object initializers. In this case, we have an order object that we've freshly created. But you recall from, if we inspect our order class, that we have two properties, billing address and shipping address. Each of these are instances of the address class. So you can see what I've done here is when we get into the actual defining of the properties for our order, here we've set the billing address property and the shipping address property equal to new instances of the address object, and then use the object initializer syntax to fill out its initial properties. Pretty neat. So we've nested object initializers in an object initializer. Okay, so the same thing then is true with collection initializers. So here's another example. As you recall from looking at our definition of an order class, we have defined an order item property or order items property that is a list of order item objects. Here we have the creation of a new order, and we're going to set one of its properties equal to a new instance of list of order items. And now we use the object initializer syntax, or actually collection initializer syntax, to create new instances of order item and add them essentially to our list of order item. Meanwhile, we're using object initialization for each of the new instances of order item. So we can embed, first of all, two lessons. We can create a collection initializer like we've done here, this entire snippet of code, and inside of that embed multiple object initializers that will be each individual item in our new list, generic list of order items. Okay, and so then the final thing that we want to point out is that this will work for any type that implements IEnumerable. So let me copy in one last code example here. Okay, remember that IEnumerable is an interface that your classes or the .NET Framework classes can implement to promise that it has the functionality. In this case, enumerability, which means working through the ability to iterate through or to move through a collection or a grouping of objects that implement IEnumerable. So, fortunately for us, a list of integers, since it's a generic list, it will implement IEnumerable, and therefore we can use it like this instead of using an array. Okay? Here, we're creating an array list, and we're able to add each of the orders that we've been defining in all these previous steps through the use of a collection initializer. Here we have a new collection of type array list, and to that we're adding existing instances of all of the orders we've been creating. Okay? So to wrap up, we're starting out today building a foundation that we lay a discussion of LINQ on top of. And while LINQ doesn't necessarily need object and collection initializers to do its work, you're often going to see these in examples that we create and that you see throughout the internet. You'll see these notions paired together as you look through code. It's definitely a complementary concept and a really elegant addition to the language. So in the next video, we're going to continue building on this theme of ramping up to the big LINQ introduction. So we'll see you in the next video. Thank you.